Hi gents, we're gonna do more of some mock papers here, just to give a shot at it. Yeah, obviously things have totally changed with the or with the junior cert as time has gone by. We'll talk about that when we know exactly what's going on. What I'm gonna do is just from your own mock paper, paper 2, question 8, because it's nice and easy to draw. I will come back. I'll do the stats question there, but it's just going to take a while just to get that together. Okay, we have a capsule here like that. We're told that it's 16 millimeters from there to there, and from top there it's 6.6 millimeters. Okay, show that the volume of the capsule is something. So that's the whole capsule. So the capsule is made up of two things. It's made up of a cylinder and it's made up of a sphere. Okay, this is in three dimensions. It's worth pointing out. Okay, so this is pi r squared h. So pi is pi. The radius of the cylinder, the cylindrical part here, the radius of that is of course half of this thing here, so that's going to be 3.3 squared, and its height is 16. So just ask this to the nearest whole number, but I wouldn't write this part to the nearest whole number. I'd write everything in first, and then at the very end do the whole number. So 3.3 squared, I've got that. I then multiply it by 16. So this thing here is 4356 over 25 pi. That's how many pi's we have here. Now for a sphere, it's 4/3 pi r cubed. Why is it a sphere? Because there's two hemispheres off the end, so two hemispheres is obviously one sphere. So it's 4/3 times pi times, I said r cubed, I think. You can rewind and check if I really did. So sorry, it's not 3 cubed, but 3.3 cubed. So let's do that. 3.3 power of 3, there it is, times 4 divided by 3. What I'm getting is the beautiful number 11979 over 250 pi. So we just need to add those two numbers together in order to get our answer. So it's that many pi's added to 4356 pi over 25. Now, once this is the nearest whole number, this comes out to me as 697.92 blah 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 698 centimeters. No, not centimeters. Watch out for it. Millimeters cubed. The whole thing was in millimeters. Easy one to get. And look at that. It actually says show that the volume is that. They even kindly give you the thing. Now to get as many marks as you can, formula, fill in the numbers, and just let your calculator do the work and go from there. Okay, the manufacturer of cod liver oil uses tanks, to fill the manufacturer uses tanks of cod liver oil to fill the capsules. How many capsules can they fill out of a 100-liter tank if they expect to lose 5% of the oil in the manufacturing process? Okay, so it actually tells you that 1 liter is equal to 1 million millimeters. Millimeters, it's got me again. Not used to dealing with them. Millimeters cubed. 1 liter is also equal to 1,000 centimeters cubed. That's worth knowing as well. Okay, keep those things in your head. In fact, this is a good learning moment. To go from millimeters to centimeters, you're probably thinking, well, hold on, 1 centimeter is 10 millimeters. So what's the case? If I go from 1 centimeter cubed, is this now just 10 millimeters cubed? Okay, is that the case? And it's not. It's tricky. Okay, it's tricky. If you think about what 1 centimeter cubed is, the volume of this box here, if that's 1 centimeter and that's 1 centimeter and that's 1 centimeter, the volume is 1 centimeter cubed. But if you take that same box and you write it this time as millimeters, that's 10 millimeters. That's 10, that's 10 millimeters. And this is 10 millimeters. So the volume is equal to, well, it's equal to 10 times 10 times 10. So the volume is actually equal to 1,000 millimeters cubed. They're the same. 1 centimeters cubed is actually 1,000 millimeters cubed. Why? Because you're multiplying by 10 for every centimeter that there is there, and there are 3 of them. Okay, when you go from centimeters to centimeters cubed, you're multiplying by 10, and by 10 again. So in our first one, it was just centimeters to millimeters. You multiply by 10. But the other one, you need to multiply 10 and 10 again on top of your original 10 in order to get that. So that's just a little tricky thing. What I would be doing, just, pro tip, I would never, I really hate going from centimeters cubed to millimeters cubed just for that reason. You can't work it out if you sit down and think about it. It's just easier just to change everything at the beginning. Okay, just go for it nice and easy. Okay, and go from there. So what do we have? We're going to have 100 liters apparently. So we've got 100 of these things. What are these? These look like millions. They are. So we have 100 million millimeters cubed. Okay, so if we're going to lose 5%, okay, well, think about it. If you have 100 million and you lose 5%, you are losing 5 million. So we will have 95 million left over. Okay, another way you can do that is you can say if you're losing 5%, you're having 95%, or you're left with 95%. 95 out of 100, that's what 95% is. So that's 0.95. You just take that multiplied by 0.95. Or to get 5%, multiply by 0.05, find out what that figure is, and take it away. It's obviously 5 million, which you would take away. So this is what you are left with. We have this many millimeters cubed. Each one of these things here is a capsule. So you want to see how many capsules are in there. So of course, that's just division there. Give your answer to 3 significant figures. Is it asking how many full capsules can we get? Yeah, it is. So 95, 1, 2, 3, 1, 2, 3, that's million, yeah, divided by 698. So they can make, assuming the spillage, 136,103.159. What is this significant figures? That just means from the front. That's the first, that's the second, that's the third significant figure. So it's 136. This tells you whether to round up or down with your 6. I've left it as it is. So it'd be 0, 0, 0. That's how many? 136,000. Okay. If you were asked to do that, for instance, 2 significant figures, just have a little think of it, pause the video maybe. Have a think. If I asked you to round this number to 2 significant figures, you should say to me 1 and 3 is the second significant figure, but 6 says to put it up there. So that's what it would be. Do I need an extra 0 on there? It would be 140,000 if you were doing to 2 significant figures. To 1 significant figure, 100,000. The 3 says keep the 1 as it is. A significant figure, you're looking for the first non-zero number. Okay, if it's 0.00, I don't know, 719. If you were to do that to 1 significant figure, it would just be that. It's the first non-zero number. Okay, if I were to put a 1 there, and if I were to say, write this to 2 significant figures, this is the first significant figure, this is still the second. Okay, so it's the, you start where you have the first non-zero number. So this will be 1.0, it would just be 1. Okay, just to sort of get you a few little bits along the way. Did I actually answer the question? Hopefully I did. 136,000 is what I'm getting there. The liquid capsules are sold in boxes of 24. Liquid capsules are sold in boxes of 24. So there are 24 capsule in a box. I presume that's what it's saying. Yeah. In the box, the capsules are standing upright, one hemispherical rows and columns list all the ways in which it can be done. Okay, so for 24, you could have just 24 all in a row. Okay, so 1 by 24 rows and columns. You could have 2 and 12. You could have 3 and 8. You could have 4 and 6. Those are all the different ways in which they could be arranged. Yeah, that's it. Okay. Of all the options you have listed, which one do you think is the best arrangement? So this bit is actually important, because if you just think about it in terms of the practicalities, let's say you were going to build this thing here, what might be important as to what sort of area or volume it is that you're dealing with. So what's this? Obviously they're all 24, but what you might want to do is you might want like a more square shape. Okay, you might want to do it like that, rather than just have like one ridiculously long box like that. So I would think that you might be looking at 4 by 6 might be a nice way to do it, because that is a little bit more boxy as you're doing it. So that seems like a reasonable way to proceed. Okay. So actually they are asking us to go ahead and to do this thing here. So we're really gonna have to think about this here. So the volume of the smallest box needed to hold the capsules. So let's see. I'll just reread the question. In the box, the capsules are all standing upright on the hemisphere. Okay, so we'll take that to be it. Okay, in rows and in columns. So let's just, for instance, we'll do our 4 by 6. So there's our 4, and then 6 going this way. Here, 1, 2, 3, 4, 5, 6. Okay, perfect. Okay, so for instance, this thing here. Now, let's think about it. Its length going down the way. I'm gonna have to go all the way up here. It's 16 millimeters, and we need to add on this bit here. Now that bit is the radius, as well as that bit there. So you can just add on 2 radii to get that full length, which is actually just 6.6. So it's 22.6 is our whole length going down for each one. 22.6 for each one. Now going across the way, what's each one? And I think you can see there going across the way, it is just 6.6. 6.6. Well, okay, let's just do the maths as they say. Oh yeah, as well as going across, what would that be? That length there, okay, that's also the width of one particular pill or capsule, as they're calling it. So that's going to be 6.6. Okay, so let's work it out. We have 22.6 times 6. I wonder, do they want us to 1 by 24 and 24 by 1 or anything like that? Do wonder about that. 22.6 multiplied by 6. Just a del. Sorry. So this whole length here is 678 over 5, or put another way, 135.6. 6.6 going across the way. That's why I was just saying it might be a bit better to do it like that. That's going to be 26.4, and then multiplied by 6. So volume LBH 135 0.6 times 26.4 times 6.6. I'll just show you what the other volume is going to be. So 135.6 times 26.4 times 6.6. And that is going to be 23626.944. Those are millimeters cubed. Now, if we'd done it the other way around, so if you just had instead packed it like this thing here, okay, like that. So this time we've got 6 going across here, and coming down the way it's that. So in this case, it's going to be 22.6 times 4. So we've only 4 going down the way, so it's 90.4. Going across the way, it's 6.6 multiplied by 6 this time. So that is 39.6. And it's still got 6.6 as its depth here. So 90.4 times 39.6 multiplied by 6.6. And that is, of course, the same answer, because all we did was just rotated it along the way. So it's just to show you that that is going to be consistent no matter which way you go. But if you were to take it as a different one, and we'll just do one of those. We'll do our 3 by 8, for instance. Okay, what do we get? We get 22.6. We've multiplied by 3. It's got 3 capsules going down, and that's 67.8. If we go across the way, it's 6.6 multiplied by, what's this now? This is by 8 this time. So that's 52.8. And again, it's multiplying by 6.6. Now watch our volume here. Okay, obviously we want the lowest volume possible typically. So 67.8. I'll write it in actually here, 67.8 as well as my calculator, times 52.8 times 6.6 times 52.8 times 6.6, and we get, hey presto, 23626.944. It is exactly the same. So it turns out that whichever way you go and deal with this, and actually one of the fastest ways to see it is to go and do it with the 1 by 24. So in that case, you'd have, for instance, 6.6 times 24. That is 158.4. You'd have that multiplied by 22.6 and then multiplied by 6.6, and it comes out the exact same. So just in terms of our design, you know, it really is about what sort of box do we want to create. Do we want to just create a giant long tube, or do we want it to be boxy? And I would think that we want to be boxy inside there, just a little bit easier to store or whatever. Okay, we shall do question 9. So this is a trigonometry question here. A vertical cliff is standing at the edge of the sea as shown in the diagram. Okay, so we've got some sort of cliff, whatever. It's actually a vertical cliff, so we'll just say straight there and into the ocean. Okay, what piece of equipment? Sam's on a boat, and he's at B. Yes, there's B. And this is going to be C. What could he use to measure? The device, we mentioned this when I saw you very briefly, is a clinometer. Yeah, excuse me, a clinometer. Okay, this is a right angle because it is straight up. We're told that this is 75 degrees. Sam is in a rowboat. It's 50 meters from the cliff. Find the vertical height. So this is from A to D of the cliff, if this is truly the case. So this is a right angle triangle. We want to know, we'll call it x, we want to know the opposite, we've got the adjacent. So we'll say tan 75 is equal to opposite x over adjacent 50. Multiply both sides by 50, 50 tan 75. It asks us to give it to one decimal place. So we'll type that in, 50 tan 75. That's 186.6, and those things are meters. Okay, let's see what does it do. Is it going to sail away or something? The point C is 3 times further away from the base of the cliff. Okay, so if it's 3 times further away from the base of the cliff, it's 150 meters away, which means that that is going to be 100. How far, maybe we should just check that. The point C is 3 times as far away from the base of the cliff as point B is. Yeah, so it's 150. How far is the point C from the base of the cliff? Well, it's just 150. Sam rode in a straight, and it's 100 from B, is what I'm writing in there. Sam rode in a straight line from B to C at a constant speed of 2.5 meters per second. How long did it take him to get there? Let's get our fantastic triangle. And it's asking about time. Time is therefore equal to distance, which is 100 meters. That's what he's gone. And his speed, which is 2.5. So 100 divided by 2.5 is 40. He's a bloody fast rower. 40 seconds. Is that fast? I don't know. Yeah, I'm not sure if that's fast or not. Can't say how much of a rower. Sam thinks that because the point C is 3 times further away from the base of the cliff than B, then the angle of elevation will be 1/3 of that. Sam. Do we agree with him? Of course we don't agree with him. Okay, the upshot of that would be that if, where this is 75 degrees, if we went to the 25 meter mark using Sam's crazy logic, it would mean that when you look up, it would be 150 meters. Well, of course it can't be, because straight up is 90. So there's no way that's going to be 150. So Sam, tragically mistaken. So would we agree with him? Certainly not. So if we figure out what is the angle here, we'll call it theta. What are we going to say? We're going to say, well, we know what x is now. We know what the opposite is. So it's going to be tan again. Tan theta is equal to the opposite, which is 186.6, divided by the adjacent. The adjacent is 150. And to figure out what theta is, we do tan inverse that number there. 186.6 over 150. So let's do that. And the whole point here is not going to be 75 divided by 3. It's not going to be 35, because it does ask us to use calculations to back it up. So 186.6 over 150. And this is 51.2 degrees. So of course it's shallower, but it's not 1/3 of it. Okay, it doesn't work like that. It's not a linear thing as we go along. Okay, we will click over to question 11. Yeah, we spent a bit of time doing this, didn't we? Just beforehand, our little famous circle theorems. So we've P, we've R, we've S, and we've got Q. Oh, wow, by my standards, that was pretty atrocious. Yeah, so just join that to that. Okay, so this is really a standing on the same arc question, I can almost tell, but you kind of need to rotate your mind slightly or just break your neck so that you're looking at it such that this is the arc there. Okay, that's the arc there. I think that's the best way to think about it. Okay, it tells us that this thing here is 55 degrees. You can also think of the arc as being here. Okay, If you do think of the arc as being there, what we've done is we've joined it from there to here. Okay, so we've joined the circumference there. I do it horribly just so we can really see it, and it makes it easier for me to rub it out. So this thing here is going to be 55 degrees. That bit has to be so. Okay, they also tell us that that length is equal to that length, which is quite handy. We are dealing with isosceles triangles. So if we call this thing theta, that thing will be theta. So we can say that theta plus 55 equals 180. So 2 thetas is equal to, we'll do that out, 125. So 180 minus 55, 125, we divide it by 2, 62.5. Excuse me, I beg your pardon. So 125 theta is equal to 62.5. And we can start working stuff out here. Okay, we can say that this thing here is also 62.5. Why? Vertically opposite angles. I should probably check what they're actually asking us to get. They asked us first of all to get from T to Q to S. Well, we did that 55. Justify your answer. Angles standing on the same arc. Get T to P to OR. So from T to P to OR, that's that one there. Okay, so we'll say we'll call it gamma. Gamma plus 55 plus 62.5 is equal to 180. There, 3 angles in a triangle. So 180 minus the 55 minus 62.5, gamma is equal to also 62.5. Well, of course it is. If you've got 55 in here and 62.5 and the other one was 62.5, you were of course dealing with the same thing over there. Okay, so I've told you what the reason is in each case. You would of course need to write it down as well. Okay, the diagram shows a necklace. This is why I really hate doing these questions. We have to actually draw some stuff out. Okay, and it asks us to use to get the horizontal bar because we are told that this is 90 degrees despite the way that I've drawn it. So that's 3.54. This is 3.54 as well. So we've got an isosceles triangle going on, and use that to show that to the nearest centimeter this thing is 5. Well, remember it's a squared plus b squared equals c squared. That's Pythagoras, where c has to be the hypotenuse opposite the right angle. That's our little 5 there. Don't put that in, just show that that's what we get. Okay, it's just a classier way to do it rather than relying on someone else's telling you what it is. We'll just figure it out what it is. So 3.54, we square it, and we add it to itself, or we double it, and I see here that's 25.0632 equals c squared. C is equal to the square root of that thing. I'll just call it ANS because you can use the ANS button on your calculator, and that is 5.00 blah. So c is equal to those centimeters, presumably they are. Okay, the curved edge of the bottom part of the pendant centered at the top. Find the length of the curved edge. Okay, what is this part of? This here is part of a circle. Okay, how much of a circle is it? It is, if we had a full circle like this, and if we were to actually go at right angles, you can see here that this would be a quarter of it. So if we're just trying to get this bit here, well, if you just get the whole thing, the whole way around, this is just going to be a quarter of it. So what's that whole thing around called? Feel free to shout it out in your own home weirdly. It is not the area, but it is the circumference. Circumference is equal to 2 pi r. So you can go and get the whole one, or you can just get that bit there. To get just the regional bit, I'll call it CR for a second, you would say it's theta out of 360, where theta is the angle. So it's 90 degrees out of a full 360. That's where you're getting the quarter from, if you like. And it's 2 times pi times r, and the radius we already know is 3.54. And it asks us to get this to 2 decimal places. So let's do that. So there's pi multiplied by 3.54 multiplied by 2, and then we get that and divided by 4 because it's a quarter of it. So this circumference part here, just of that particular region, that is equal to 2 decimal places, 5.56. Okay, so far so good. Those things were, again, centimeters. Okay, hence find the total length of silver needed to make the pendant. Well, to make the pendant, you're going to need 5.56, and you're going to also need our 3.54, sorry. So 3.54 times 2, or added to itself, added to 5.56. We're just adding all those along. Total silver is equal to 12.64 centimeters. Some free marks. Find the area of the hollow bit. Find this bit in there, the shaded region, beautifully shaded region here. So this thing here, to get the area of a triangle, it's half the base times the perpendicular height. I think that's what they're asking for. Is that the actual hollow bit? Maybe not. The edge is dependent on the triangular part is hollow. It is, yeah, we'll just double check that that was the case. Okay, the base. Well, don't take the base to be this bit here at the bottom, because you would then need to know that perpendicular height, which you don't necessarily know. Instead, take the base as 3.54, and then the perpendicular height, excuse me, will also be that. Excuse me, 3.54 squared, and divided by 2. The area of the hollow bit, let's say to anything, to 1 decimal place, got to change it all the time, is 6. It says 26, so that's 6.3 centimeters squared. Find the area of the gem needed to make the pendant. That is the shaded area there. Aha. So there was a reason for them to go and get us the triangular part here, because remember, what is this whole thing? It is just the whole thing, as we see it in there. It's a quarter of a circle. So if you go and get what that area is, the area of a circle is equal to pi or squared. And we're specifically getting 1/4 of it, or 90 over 360, as we were saying beforehand, if you wanted to do that. So it's times pi, and it's 3.54 squared. So let's go do that. 3.54 squared divided by 4 and multiplied by pi. That area of that whole region there is equal to 9.84. I don't know what do they want this to. 1 decimal place. We'll keep it as that for the moment. Now what we're just after getting, so we're after getting the triangle that's above that. So if we just take away that triangle, it will leave us with the pendant, or the gem, or whatever we want to call it. So the area of the pendant, it's the whole area, 9.84, and subtract from that the triangle, which was 6.3, so minus 6.3, and this was again to 1 decimal place, so the pendant is 3.5, and those are centimeters squared. Why? It's area. It's area, so that's what we're dealing with. So keep hitting that. Okay, what do you reckon? Can we finish up with question 13? I will come back to the stats question for sure. Okay. In a certain city, the probability of it snowing one day in winter is 0.2. Okay, so they've actually made what's called a little tree diagram. So 0.2. And they fill that in. Okay, so this is to say that there's snow, and this is no snow. Okay, well, if there's odds of snow are 0.2, no snow is 0.8 because that's 0.8, sorry, because they have to go and add together to give 1. So it's either snowing or not snowing. Okay. It says, if it snows on that day, the probability that it snows the following day is 0.7. Okay, so this is that it snows again. Now remember, on this day, this is a new day here, so it is either going to be snowing, which is 0.7, or not snowing. No snow. Well, that's got to be 0.3. Okay, those are our only two options. And here, if it wasn't snowing, the odds that it will be snowing the next day is 0.1. So the odds that it is not snowing will be 0.9. You have to treat those two things differently. Okay, so what it's asking you is use the information to fill that in, hence calculate all the possible ones here. So this is the odds that it snows on a particular day and it snows the next day. So if you need to do one thing and the other, remember what you do with the probabilities. You multiply, hopefully you remember that. So it's 0.2 times 0.7. So 0.14 is what we're looking at there. 0.2 times 0.3 is equal to 0.06. 0.8 times 0.1 is of course 0.08, and 0.8 times 0.9 is 0.72. If you add up all those possibilities together, you should get 1, because it will cover every single eventuality. Use the tree diagram to complete the following sentences. The probability that it snows 2 days in a row. So the probability that it snows, so what do we need it to? We needed to snow and snow again. We just saw that that one was 0.14. The probability that it snows on at least one day. At least one day. So remember that it would snow 2 days in a row. You needed snow and snow. When you see something and something, you multiply. In this case, that it snows on at least one a day. Okay, at least one day. Let's tick off. Has this one gone on one day? It has. It's gone on 2, but that is still at least one day. It didn't say one day only. Okay. What about this one? Is this one okay? It is, because it snowed on the first day, it didn't on the second, but it has snowed at least one day. This one is fine. Didn't snow the first day, did the second. This is the one that's not fine. Okay, so there's a couple of ways that you can think about it. If you need something, you know, it can be this one, or this one, or this one. So when you have something or something or something, rule of thumb is you can add them together. Another way to think about it is, well, the odds of everything, you know, all has to happen is 1. So if that's not included, it's just 1 minus that. That would be, you know, the other way of looking at it. So this is 0.28. So the odds of there being snow on at least one of the days is 0.28. Okay, that one I have to say is probably trickier than most of the ones that I would have seen for the junior cert. I wouldn't be expecting one to be quite that tough as you went along. Okay, gents, it's a long enough video. We've done quite a bit inside it. Hopefully you found it useful. Thanks. Bye.